So when you get to that document, it looks like this. So it has a series of parts. First part's kind of individual. You're going to walk through just properties of elements, so metals versus non-metals versus some of the similarities that they could contain. There are 2 links for that. I said be creative. You can make a big table. You can make a Venn diagram. Put some color into it because your brain really remembers colored-coded things better than just black and white. So your brain is hardwired to kind of differentiate that. So that's why I said try to make it a little creative, pictures and details. There's some extra stuff here, but this tutorial is really good. So some of this will be reviewed from middle school, but it's a good review to start with. After that, you'll be working in groups of 2 and 3, 2 to 3, and you can include this in your notes because this is the start of your notes. This is the start of us talking about periodic table more and then trends that relate to that. So you can look here, see there's properties at the top, and then it tells you what to do according to your group work activities. So guys, just hold on one second, okay? Thanks. So you'll see instructions here. After that, you'll be working for 15, I'm hoping 15 minutes on this periodic table mystery. And I have to give you a periodic table for this. This is the coolest thing. I love it. It's like a little puzzle. If you like a bit of a challenge, it's here for you. We'll check it afterwards. And it's really in regard to properties of elements. And then I'll talk about the 4th part later. Okay? So I'm going to put this back up here. Start individually. And then you guys can get into groups as you achieve those parts. Okay? Okay, I'm mind reading and you're like, what? Okay, we're working here. Let's see what you guys are. So if you want some colors, some markers, etc., you can use that colored paper to make a whole book for yourself. Do something that works for you. I don't know what kind of music we have today. Let's see. All right, so you have made some discoveries, right? So I'm going to ask for some of those discoveries to be said the best you can. And then we are talking about what these trends, like what these properties are representing a whole lot more Monday, but I just want you to get a general idea first, okay? So Munir, what was the first trend you guys investigated? Was it radius?
The radius of the element.
Okay, so I want everybody on their paper someplace. Sketch out just a little brief periodic table. Just do the little castle look in the middle area, okay? Alright, so we have a sketched out periodic table. So Munir's group, can you tell me one direction of the trend? So tell me either the period or the group, what you noticed. Okay, so I'm going to stop you there, okay? So from top to bottom, she means in a group, right? So from the top of the group to the bottom of the group, the radius is getting bigger. I'm only a fan of writing big to small. I don't like to think small to big. It's just not natural for me. So that's how I'm describing this from here on out, okay? So I'm going to draw an arrow down and say increasing radius. Okay, so I want you to follow my lead here, okay? Kern's group, what was the other, so radius, this was the group trend. What was the period trend? Next groups, get ready for the next questions. They're coming here, okay?
Oh, wait, period from
for radius, yep.
We did not like that one.
All right, well then I want you to look at it now. So look on the graph, look at atomic radius, look at argon or neon. So give me one of those sizes.
So, from left to right,
Okay, from left to right, I can do that.
the radius decreases.
Okay, so then I want to talk increasing terms. So how would I describe this in an increase? So from right to left, so from group 8 to group 1, the radius is increasing. Okay, so we're good so far. We have 2 arrows on our periodic table, yes?
Yeah.
All right, Andrew's group, give me the next trend you guys investigated. Electronegativity. All right, electronegativity. Here we go. Tell me one of the directions that you are period or group trend.
We said that it increases and something to the right.
Okay, so give me a period or a group trend first. Yeah, I know you can combine them, but I'm just looking for one at a time.
To the right.
Okay, so they're saying electronegativity increases from left to right. So I'm going to go below the periodic table. I'm drawing an arrow. And I'm saying increasing En. If I say En, can you guys understand that's electronegativity? I'm just abbreviating. Okay. All right. Kendall's group. Electronegativity. Tell me the period. I mean the group trend. They told me the period trend.
We talked about like how it increases for the top right corner and increases like in the bottom.
Okay, so you guys did a diagonal.
Yeah.
So can you interpret that in a vertical fashion?
So like
There you go. Okay, so it increases from bottom to top. So we're going to write electronegativity increases from the bottom to the top. Okay, Cole's group, next trend. Ionization energy. Okay, give me either the period or the group trend.
As you move down within the group, well,
Yeah. Okay, so as I go up a group, it's increasing. So I'm just going to tack that on here. So it's following the same direction electronegativity is. So ionization energy increases as you go up a group. So IE for ionization energy. Okay? Jacob's group, ionization energy for the period.
It increases from left to right.
Same as electronegativity, right? So I'm going to tack that on here. It's increasing from left to right. IE follows the same directional trend as electronegativity. CJ's group, next. You guys kind of have the wonky one, so I'll work with you here. So this is electron affinity, right?
it seemed a little bit scattered, but it seemed like for the most part,
For the most part, it was.
thought it was increasing from bottom to top.
Okay, so it is. So it's wonky. This one's a roller coaster, we're right, but it does generally increase from bottom to top. So a group trend, I'm tacking it on here. Electron affinity, it's going to fit in with electronegativity and ionization energy. Can you guys finish that up and tell me the period version? Oh, sorry, no, hold on. Bryce's group, I don't think I got you guys. Generally increases from left to right, so it's following the same directional trend as electronegativity and ionization energy. Okay, so we did this exercise, so I wanted you to first look at data, look at the periodic table to see how these trends kind of come to life. What these trends mean are basically how reactive every element on the periodic table is. But what you have to know the trends. You have to know how like these work, okay? So you notice that who's the outlier here? Radius, okay, radius this. Give me 2 L's. Okay, so I want you to, so I'm mimicking you, okay? So take your right hand up and then crank it to the left. Okay, so we have the radius, right hand radius. Your finger points in the increasing direction, so your finger points are arrows. And then take your left and flip it and make a little picture. You got your own little periodic table, okay? So you got your own little periodic table. You see it, right? Atomic radius increases to the left and down. Everything else increases to the right and up. Got it?
Yeah.
You will do this on the test. You're going to look around. You'll be like, okay, you're going to do this. Okay, this has helped me since 10th grade. Remember the trends. Okay, now if you're not quite done with the trends, go ahead and finish that up. Send me a team captain to come do the periodic table mystery. Okay, this is the fun part. Grab one of those, one for your group.
One per group?
One per group, yep. And I will get you started here, okay? That's not what I was looking for. Okay. Alright, so I'm going to explain this before you start without me, okay? So I'm explaining this first. So eyes up here, if you're still looking at your computer, I need you to look up here for me, okay? So periodic table mystery, introduction, it gives you a little bit about Dmitry Mendeleev, who's the scientist that helped predict where the elements are on the periodic table. I'll let you read that in a second. Pre-activity questions, this does take just maybe 2 minutes of your time. You'll do that in just a moment. Procedure. Place the unknown, so you'll see a slew of letters here. These are all unknown elements. They're just elements on the periodic table, but I'm giving them a code name, Z, U, K, Y, whatever, okay? See if you can understand the patterns. The following sets of elements belong together in groups. When I say group, you think what? Column, right? So, for example, Z, R, D all belong in the same column. Q, K, A all belong in the same column. So once you figure out who one of them are, you know who the rest of them could be because they're in the same column. Got it? Okay, so that's the trick. All right, so here's the periodic table that you guys are utilizing. You will only use the first 4 periods. Okay, so 1, 2, 3, 4. So maybe put a little slash. You won't be using the bottom ones at all. Okay, only the first 4 periods. So once you figure out one, you can figure out the others. So let me get you started, okay? So here's all the clues. You kind of following with me online? If you can't see this up here, I understand. So I'm going to say, I think the 4th clue is a dead giveaway, okay? So I see total, oh, well, no, let's do U. Let's just do the first one. U has a total of 6 electrons in its neutral atom. Who could that be? Carbon. 6 electrons, neutral, means electrons equals protons. This is carbon. So put U where carbon exists on the periodic table. Got it? Okay, so looking back at the little grouping system, U belongs with who else? G and N. So you know G and N are going to be either silicon or germanium or vice versa. So I would put above that little group on the periodic table, which is group 6A, right? I would put G, U, and N. I know that's a bad example here, but we have G, U, and N. U is the first letter, and then either G and N are going to go there or there based on the other clues that are achieved. Do you understand?
Yes.
Perfect. Go. This is the fun part. It's like a jigsaw.
What? Which sits out?
Some of the clues are really easy, some of them are hard. Take the hard one.
No, there's only 2. There's only 2. Somebody use my stuff. Oh yeah, that's Great reason.